3,630 kilometer, we got some kilometers here, Tour de France in 92.5 hours. I have kilometers and I have hours. Traveling at his average speed, how long would be measured in what units? How long would be measured in what units? Time, hours. Would it take Lance Armstrong to ride 295 kilometers? All right, I'm trying to find how long, right? Yep. I'm gonna let X be the time. Okay. Now, here's how this works. I am going to compare Lance's time in kilometers here to his time in kilometers here, using a proportion. Here's one way you could do it, and I'm going to label it. 3,630 kilometers took, I'm going to put it over 92.5 hours. Why am I putting those things on top of one another? Because those were done at the same time. Okay. Would you write an equal sign? Yes. Now, if I put kilometers on the top here, I have to put kilometers on the top here. You've got to keep your proportions equal units, okay? So what should I put on the top here then? 295 kilometers, and then X hours down here. Now, I don't need the units anymore. I just put them down there to help me write the proportion. This is not a difficult one to solve. Let's do it. All right. So, I'm going to have 3630x equals 92.5 times 295. Okay, so I get 3630x equals 27,287.5. Is that what you were saying, Abby?
Yes.
Okay. Now what should we do? Do you mean divide or subtract? Okay. Yep, he's right. We're going to divide both sides by 3630. Now, again, this is where, with larger problems like this, you're going to want to have a calculator, unless you want to do that in your head. All right, so it looks like it's going to take, let's round to the nearest tenth. This is in hours, 7.5 hours to do that. Christy. You can. So you can do this times this divided by that in one step. Yep. All right. Here's how we work with a scale. The scale of a map is 1 inch to 10 miles. If you've ever looked on a map and seen a scale like this, that means every inch on the map is like 10 miles in real life. Okay? So I'm comparing inches to miles. All right. The map distance from Valcaria to Gifford is 2.25 inches. How far is the actual distance? All right, let's write down a variable. D, I'll write for distance. How is the distance measured? In inches or in miles?
In miles.
In miles. All right, so I'm going to write down what I know is 1 inch is 10 miles. equals. You guys tell me what I should put on the top. 2.25 inches over D, or whatever X. Okay, now I'm going to show you another proportion on the board. Now I'll show it to you right here. Some people like to do it this way. They like to say 1 inch to 2.25 inches, and I say that's fine, as long as then you put the 1 inch with its correct miles on top. What does 1 inch go with? 10 miles, and the 2.25 goes with D. Yeah. Now I'm going to show you, when you cross multiply, aren't you going to get the same thing with those two proportions? Because you're going to get D and then 10 times 2.25. Here you would get D and 10 times. All right, so does it matter? No, you can do it either way. Here's what you can't do. You can't put 1 inch and 2.25 inches on top and bottom. That's really the only thing that you can't do. You have to put alike things either stacked on top of each other or next to each other. So here we go. We cross multiply. We get D times 1, or D, equals 10 times 2.25. Can we do 10 times 2.25 in our heads?
Yes.
I tutored somebody in 6th grade math this year, and you guys do this in 6th grade math with no calculators. Yeah, move the decimal over. 22.5 miles. Alrighty. You may or may not know this, but at different times of day, depending on the height of the sun, sometimes your shadow is longer than other times. Okay. However, if you were comparing two objects that were at the same time of day, their shadows should be proportional to their object. So it says a flagpole casts a shadow 102 feet long. So I'm going to draw a flagpole. I'm going to draw the sun up here, okay, and then I'm going to draw its shadow being 102 feet long. So we're going to assume at the same time of day, a 6-foot man, so I'll draw a stick figure because I'm not a very good drawer, and this man is 6 feet tall. So I'm going to put his height next to him. Okay. He casts a shadow 17 feet long. Oh no, we have feet and feet and feet and feet. Yikes. How am I going to do this one? I want to find the height of the flagpole. Clayton, are you okay if I put an X here for the height of the flagpole? Okay. Tell me what I'm going to do here.
You do,
Mm-hmm.
oh yeah, you put 1, 2, and 17 like on the top, and you can put like 6 feet and then X and 1.
Okay, he said I can do 102 on top, because they're shadows, right? Shadows and shadows. And then he said you could do X here and 6 here. You can. That is a correct proportion. Can somebody tell me another correct proportion? What do you think, Chloe? What do you think, Riley? Can you put 6 what? Does the 6 compare? But look at the picture. Is 102 the shadow of the 6-foot man? No. You could put 17 under 6. You could also put the height of the flagpole under 6 because they're the same thing. So we could do this. What if I said I want to compare the heights of the objects and the shadows? I would put the height of the flagpole over the height of the man, and then the shadow of the flagpole. Okay, here's my point to you. When you cross multiply this, do you see how you have x times 17? When you cross multiply this, don't you still have x times 17? These are, either way of thinking of it, they're both going to work. Alright, let's do it. So we have 17x equals 102 times 6. What do we get there? Christy, what did you get for 102? Or did you do all the whole thing already? What did you get for your final answer? Okay. So 102 times 6 is 612, and then she divided both sides by 17. Okay. Do you have questions so far? Okay, so now you have a whiteboard, right? Can you get that whiteboard out, please?